Interesting. This will be my first recording with the Smart Document camera, and Screencastify doesn't seem to interact in a very friendly way with the document camera. So we'll just see if it works, and if not, I'll go back to the old one. The resolution on the Smart Document camera is way better than the resolution on that IPEVO camera I was using before. Okay, we're looking at problem 46, and we want to find the center of mass of the three mass systems shown in the diagram relative to the 1 kilogram mass. So that statement, relative to the 1 kilogram mass, means that we should take our origin at the 1 kilogram mass. So here's what my diagram should look like. These are essentially particles. So I'm looking at center of mass of a system of particles. My 1 kilogram mass is here. I'll call it 1, like object 1. It could be A if that's easier. No, we'll just leave it as 1. Then I have 1.5 kilograms here. This is mass 2. And then I have 1.1 kilogram a little bit further along here. 1.1 kilogram, like so. Okay, or whoops, shoot, I need to be consistent. That'll be mass 3. So I want to figure out where the average position of these three masses are. I would guess that it's a little bit cheated towards mass 2, the 1.5 kilogram mass, because that is the biggest mass of the three. All right, so the idea is the position of the center of mass is the average position of mass. So I look at how much mass in object 1 I have and where it lies, how much mass I have in object 2, where it lies, and how much mass I have in object 3 and where it lies. Then, because I'm taking the average, I divide by the total of the mass in the system. So I look at 1 kilogram and its position along the x-axis. This is x, I forgot to label it. It's at 0. I look at mass 2. It is 1.5 kilograms, and its position along the x-axis. According to the diagram, it is at 0.5 meters from x equals 0. And then I look at the third mass, 1.1 kilogram, times where it lies. So it's at 0.5 plus 0.25, 0.75 meters from x equals 0. Then I divide the whole thing by the total mass. So 1 plus 1.5 plus 1.1, so 3.6 kilograms. Okay, this is the average position of mass along the x-axis for these three objects. So 0 plus, I'm not going to be able to do this in my head. So now you can see my trusty calculator off to the side. 1.5 times 0.5. So 0.75. The units here are kilogram meter. 1.1 times 0.75. 0.825 kilogram meter. And then I'm dividing this mess by 3.6 kilograms. We have kilogram meter plus kilogram meter divided by kilogram. So my answer, position, the position of the center of mass, is in kilograms. That's great. So 0.75 plus 0.825 divided by total mass, 3.6, gives me a position of 0.4375. I mean, I'm using too many decimals, but 0.4375 meters. So as I suspected, the center of mass lies pretty much closest to the largest object at 0.4375 meters.